that we have log base 10 and log base e. Now, those are special logs because those are on the face of your calculator. So let me grab my calculator here. So looking out on the left-hand column, you have a common log right next to the button 7, and next to the 4 is the natural log. And above the button is 10 to the x power, that's base 10. And then we have e to the x. Those are the exponentials. Here are the logs as buttons. Now, in the common log, base 10, you will not see a 10 at that little subscript position. If you want to put it in, you're more than welcome to. I strongly recommend it, especially if you have to solve equations when you get into calculus. All right, for our irrational number e is the value 2.718281828. It doesn't repeat, it just looks like it does, but it's irrational. And this number occurs a lot in the life sciences, economics, natural situations when involving growth and decay. That base e, all right, has its own log, which we call ln. I say ln of x because I'm thinking it as a function. Now, where did this number actually come from? It actually came from a little calculus work doing limit. This is your compounding interest formula where we have a beginning balance of $1, 1 plus an interest rate of 100%, and these are your compounds for 1 year. If you take the limit, like we talked about earlier, where n goes to infinity, so as this gets bigger and this gets bigger, you approach e. So again, I'll demonstrate on the calculator. Let me go to y equals. So from before, I'll turn this off. We don't need that anymore. We'll turn these on. So there is that expression. Now, taking the limit means when I graph it, as you can see, when I hit the trace button, I believe this is only going out to 50. But as you can see, your values for the y are getting closer and closer to e. E is up on top. There's the 2.7182818. All right, so the further I go, the closer I go to infinity, I will be approaching that value. So that's where E was generated from. Now, properties of logs. The product property, if you're multiplying two factors together inside of a log, that says you can write this as a plus of two individual logs for those factors. Again, these properties have to come from exponential properties. Remember, if you multiply like bases, you add the exponents. That's the product rule. Well, log base x is an exponent. Log base 10 of x is an exponent, and log base 10 of y is an exponent, and I'm adding them. Here, if I'm dividing, remember if you divide like bases, you subtract your exponents. So if you divide your factors inside the log, you can write these two logs as a subtraction because those are your exponents. Your power rule, that's where you had a power to a power, you multiply your exponents. So if you have an exponent inside the argument of a log, you can multiply it to the front. So r is an exponent being multiplied to an exponent. And then we have some common properties here. Log base a of 1, that's equal to 0. Again, think of your conversion rule. Base a to the power of 0 is 1. That's finding that common point, if you will. And then log base a of a itself is equal to 1. Think of it again, conversion. A to the power of 1 is a. And then I'm just going to throw a couple more up here for the natural log of 1. That's equal to 0. And then the natural log of e, that's equal to 1. So for example 6 here, we're going to start writing these into single logs. So here I have 2 times x times y. I have 3 factors, so I need 3 logs, just like we had up here in our product rule. So it'll be the common log of 2 plus the common log of x plus the common log of y. Or you can write it as log base 10 of 2 plus log base 10 of x plus log base 10 of y. Those names are interchangeable. Natural log of the square root of x over here in b. Okay, we don't have a square root property up here, so we have to change your square root, which is 2 on the ledge, 1 on the power, if you want to write them in. That's a fractional exponent of 1/2. Now that 1/2 becomes my power, which we can multiply to the front of my natural log. Part C, the natural log of x over x minus 1, that is one factor right there. Don't separate those. So natural log of x minus natural log of the binomial x minus 1. D, here we have the log of m times n cubed times q all over p squared. 1, 2, 3, 4 factors, so we need 4 logs. The common log of m plus now 3 n cubed on the inside. You can move the 3 out to the front right away, so plus 3 times log base 10 or common log of n plus the common log of q. Then p squared's in the denominator, so minus your log p squared, move the 2 out to the front. Now, I want to play the what if game here. Make sure we're all on the same page. If I put a multiplication of x in the denominator, all right, do you think we're going to have a plus log, common log of x, or because it's in the denominator, it's a minus? Hopefully you said it's a minus. Any factors in the denominator will always be minus logs. Part E, natural log of the cube root of e squared. Just like we did with the square root, we'll turn this into a fractional exponent. Your root is always your denominator. 2/3 moves to the front of the natural log. And wait a minute, we saw that before. The natural log of e is 1, so we'll substitute that out. So 2/3 times 1 is 2/3. Again here, f, x times the square root, so we're going to write this binomial x plus 2 to the 1/2 power. And then x cubed minus 3 would be smart to put parentheses around it because it is one term. So 3 factors, natural log of x plus 1/2 times the natural log of x plus 2 minus the natural log of x cubed minus 3. Don't bring the 3 out front because the whole binomial is not cubed. All right.